Assalamualaikum. My name is Amirul Rashid. So today we would like to present our assignment in discrete signal and system. Now on, I would like to present the introduction. So the discrete Fourier transform is a specific form of Fourier analysis to convert one function into another, which is we convert from time domain into a frequency domain. And for the first Fourier transform, which is FFT, is effectively implementation of DFT and use apart from other field in digital image processing. So it basically apply in digital picture, digital image from time domain and frequency domain. And also for this document will not go into the theory of FFT, but it will address the implementation of the algorithm in converting a 2D image to frequency domain and back to the image domain, which is literally the inverse of FFT. And for our project, we also using the Gaussian blur. So the Gaussian blur is the result of blurring an image by Gaussian function, which is we use the original image, then we convert it into a blur image, which is we can see literally the blur image that we use from the original image. And last one for the Laplacian is a 2D isotopic measure of the second spatial division of image. The Laplacian of the image highlight region of rapid intensity change and is therefore often used for edge detection, which is a image that will convert it to gray, which is black and white from the original image, which is there is a many color, which convert it into a gray color, which is you can only see black and white.
Assalamualaikum, my name is Nurul, binti Rodzi, and I will present for task 1. This is coding for task 1. For this task, we need to visualize original image into frequency domain using Fourier transform and reconstruct image to its real domain. For this coding, we display C output image. For figure 1, it will be originals and no changes. This is the link for original image. For figure 1, the output will get like this, the original one and no changes. For figure 2, we use gray image by using RGB to gray formula to transform from original image to gray image. And the output we get like this, gray image from original to gray image. For figure 3, is about Fourier transform. The FF2 is to transform into Fourier transform, and if we run, the output we get like this, the black image. For figure 4, is to get the center spectrum. We're using FSH. We're using FSH formula to get center spectrum. FFT shift is to move the lowest frequency into center. If we run for figure 4, we get like this. If we see closer, it has a white dot. For figure 5, we use load transform. This function, log 1 plus ABSFH FSH, is to show the load transform image. And the output will be like this. And lastly, for figure 6, is to reconstruct the original image. And if we run the reconstruct image is like figure 2. I'm try using subplot to display all image. The output we get like this, and from original image into frequency domain using full transfer and reconstruct the image into its real domain. Thank you.
Hello and Assalamualaikum. My name is Muhammad Amirul Azim bin Latef, and my number matric is B0820100025. So I'm gonna present this part for our project. This is my coding. For the figure 1 is gonna be original image, and figure 2 smooth image, sigma 2, and third one is smooth image sigma 4, and the fourth one smooth image sigma 6. Sigma x equal to 6 and sigma y equal to 1. And the last one is blur 4, smooth image sigma x equal to 8 and sigma y equal to 1. So when I'm run this coding, which be 5 figure for this part, and this is the original image, the smooth image 2, sigma 2 is blur, but it still can see the face of our face. And this is figure 3, it's still can see, but it's more blur for the part. And then this is picture 4 and smooth image blur 3. It's blur, but we can see the picture, but we didn't see our face in there. And the last one, figure 5, blur 4, smooth image sigma 8. It's all blur and we don't see our face in there. So that's all from me. That's all I'm gonna show for this part. Okay, thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Haziq bin Zamri. My matrix number is B0820100425. For my part, I will explain about task 3 in this assignment. For task 3, it asks us to detect the edges of your original image using Laplacian of Gaussian kernel. We need to observe the changes in the output as we change the standard deviation value. So we need to at least give 4 output with different standard deviation. So this is the coding for task 3. Okay, for the above one is to show the original image. Then the 4 coding below here for the output. Okay, this is the output for this coding. It has 4 output, figure 2, 3, 4, and 5 with 1 output of original image. So for this task 3, we can see that figure 2 change into black and white picture from the original image. So for figure 3, 4, and 5, when we change the standard deviation into large number, the output will become darker, as we can see figure 2, figure 3, figure 4, and figure 5. Obviously, figure 5 is the darkest output because the value of standard deviation is high than the others. Okay, that's all from me. Thank you.
Now for the conclusion. Based on this project task that we have been constructed, we be able to visualize original image of group member into frequency domain using fast Fourier transform and be able to reconstruct the image to its real domain. So basically, on the original image, we convert it from frequency domain, and then after we coding it and turn the image into a real domain by using a MATLAB that we coding it, and let's we able to know how to apply the blur effect on original image using Gaussian kernel. So basically first we insert the original image, which is there is a our member picture, and then we convert the image into a blur effect by using a Gaussian kernel, which we provided the coding from the second task. Based on the result, we found that when the value of sigma increase, the blur of the image also increase. We able to understand every line of coding in this project very well. So yes, basically we know how to construct the coding on the MATLAB. And in addition, we also be able to detect the edge of the original using Laplacian of Gaussian kernel, which is LOG. We can see the difference when we change the value of standard deviation from the task 3. When the value of standard deviation increase, the edge of original image decrease. So basically, when we increase the standard deviation, the original image will be decreased, which means the image from original image, which is there is a color, will convert into a gray color, which is they decrease the original image. So which means you in a result you only can see the color of black and white, which is the green. And that's all for today. Thank you very much.